Welcome to Comfort Learn classes. In this video, I will explain you what is the greatest integer function. So this is from PU first year, second chapter, that is relations and function. So if a function f is defined from R to R, right? So what is R? Here, this is a real number, right? This is a real number and then a real number. So if a function is defined from a real number to real number, that is, here we consider this R as per the convention domain, and this R here is codomain, right? If a function is defined from R to R, that is from if the domain and codomain are both the real numbers, then we call it as a real valued function. Okay, it is a real valued function, and the function f of x is our greatest integer function x, right? So now let me write the definition for this. How we define this greatest integer function, right? If the greatest integer function is greatest integer less than the given value. Greatest integer less than the given value. For example, if I take f of 1.5, right? So that is greatest integer 1.5 is what, right? So if you take a number line here, okay, so now here we have 1.5 somewhere here. So now if x is, if I take greatest integer function of 1.5 as per the definition, greatest integer less than the given value. So now what is the greatest integer less than 1.5? So it is 1 here. 1 is the greatest integer less than the given value. So here the value of the function is 1. So now if I take f of 1.9, that is greatest integer 1.9, right? So we have 1.9 here. Again, the greatest integer less than the given value is 1. So this is how the function is defined. So if I take f of 0.2, we have 0.2 here, then the greatest integer less than this is 0. So you will get 0. If I take f of minus 1.2, right? If I take f of minus 1.2, so we have minus 1.2 somewhere here, right? This is minus 1.2, and then here the greatest integer less than minus 1.2 is minus 2, right? So the value of the function is minus 2. So this is how the greatest integer function is defined. If you want to put this data on the graph, right? So what we get here, okay, let me take 1, 2 and 3 here, minus 1, minus 2 and then minus 3, 1, 2 and then 3, and then a 0. Fine. So now here, if it is a 0.2, right? If it is 0.2 somewhere here, the value of the function is 0. If it is 0, still it is 0. If it is 1.5, still it is 0. If it is 1, right? What is f of 1? It will be 1. So somewhere here, right? Okay, the value of the function at x is equal to 1 is 1. Again, if you take 1.1, still it is 1, 1.2, 1.3, 1.4. Till 2, the value of the function will be same, that is 1. So now if I take f of 2, then the value of the function will change. We'll get 2 here, right? And for 2.1, still it is 1. Till 2.9 or 2.999, the value of the function will be same, right? F of 2.9 is still 2, right? So now here, if I take f of minus 0.5, that will be 0. This point will be minus 1, right? So now you can take excluding 0 till minus 1, right? And same here, excluding including minus 2. So this is a greatest integer function, and even you can call it as a step function, right? And it is a discontinuous function, right? At integral points the function is discontinuous. And what is the domain and range of the function, right? So here, what is domain? Domain is an input value, right? What are the possible inputs, right? It is given here itself, all the real numbers, right? The possible inputs for the greatest integer function is all the real numbers. You take any point on the x-axis, the function is defined for that value, right? Then what is a range? Range is the possible outputs, right? So now here, if you can see, the output of the function is always some integer here. You don't get 2.1 or 2.2 as an output. It is always a integer. Either it can be positive or negative integer. So the range of the function is a z or integer. Okay. So this is our greatest integer function.